So, welcome to exercise 3. So, we have a triangle with sides x, y, z and an angle theta, so that cosine and sine theta are rational numbers. And the question is the same, whether we can get some square-free integer as area of this triangle provided x, y, and z are rational. I did start on this exercise the other day, and I got two ideas how to solve it. One was to copy the text, and the other one was to copy exercise 2. Both of them turned out to be a little complex. So I started with the book method, the method of the section, and then let's try the other one and see how that works out. Then I wanted to check something on Mabel. Mabel crashed, so here we are. So take 2. So we'll start doing what they do in the book. So what we have is the cosine relation, and the area is given by x, y, sinus to theta, that's b. So if the sides must be rational numbers, then a must be rational. And if the area must be integral, then b must be rational. So both sine and cosine to the angle must be rational. So we could see that ourselves. Next, the idea is to complete this. The idea in the section is to complete this square by adding. They add and subtract n itself. That won't work in our case. So we subtract. I don't know if we should multiply by 2 here. Well, we just use Tn. So to complete the square, this must be, or the coefficient must be plus minus 2. So that gives us 2 values for t. Subtracting 2a and multiplying by 2, dividing by b. So that was the -1, plus -1, minus a. Oh, that's it. So for those two values, we have, yes, what do we have? we have x plus minus y squared. So that's z minus z squared minus 2 minus tn. So we add tb, half tb, now what was that? Oh, that we added this equals tn. So we added tn equals x plus minus y squared. So we multiply those. So we call the two solutions plus minus. Multiply these equations. Set to the fourth minus t plus t minus n. Squared minus t plus t minus n, set n. That times that one, that times those, minus those two, and those two, product of those two. So we have to compute these two guys. So the product equals minus 16 divided by b, 1 minus a squared. And the sum one cancels and we get minus 8 divided by b, minus 8a divided by b. Was the product. Oh, this equals b squared. Lovely. Minus gives plus 8a divided by b, zn. So what was the next step? Oh, this had to be squared, by the way. Didn't it? X plus minus y. I don't know really. So, yes. So this is x minus squared. Yeah, it has to be squared. Then the dimensions fit as well, except for this one. This has dimension of area squared. Doesn't, no, I don't know. A and B being numbers. Zn, this is area to the length to the third, length to the fourth. No, length to the fourth. I don't like this. I really don't like this. Length to the second. Oh, it's z squared here. So we are right so far. So what is the argument of the book? We've just come to the second equation. This shows that the equation u to the fourth minus n squared v to the fourth has rational solutions. Oh yes, with two squares. So this is one square, x, so this is called v. Oh, I think it's in, no, it's a v. And 16b. For some reason, we should divide it by 16. I don't know why. We don't want to do that. And u equals z. We have z squared, really. So it's just z in our example, yes. Now the next step was to multiply it by u squared. Oh, whoa, 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 whoa. So this is our y, and our x can just be u squared. then we have a cubic equation being y squared equals x to the third plus 8an divided by b x to the second plus 16bx. And I don't like, shouldn't we have n squared? Oh no. So that's the equation. There was a way through it. So one just had to be very tenacious. So this ends the first video. In the next one, I'll try to copy problem 2 and do it that way. So see you soon.